My auroras just showed up in the completely wrong place. Everyone thought I was breaking the laws of physics. Wrong place? Neptune, buddy, auroras don't just show up wherever they feel like it. Did you hit your head on a comet or something?
Neptune, auroras happen at the magnetic poles. Mine show up at the Arctic and Antarctic. You know, where the magnetic field funnels particles down?
Except mine don't show up at the poles. They glow right here at my mid-latitudes. On Earth, that would be like auroras dancing over Brazil instead of Alaska.
Brazil? But that's impossible. That completely violates every rule of planetary magnetism.
Am I having a fever dream?
Okay. Explain yourself right now, Neptune. What kind of cosmic weirdness is going on with your magnetic field?
My magnetic field is tilted 47 degrees from my rotation axis. Voyager 2 discovered this back in 1989 when it flew by me.
I totally understand, Neptune. Being tilted is tough. Everyone always asks me why I'm rolling sideways like some kind of cosmic bowling ball.
Wait. If Voyager found your tilted field in 1989, why did it take 36 years to actually photograph your auroras? That's some seriously sus math.
2 words. Trihydrogencation. That's H3+, a super rare molecule that only forms during auroras and glows brilliantly in infrared light.
Oh, please. I've had H3+ in my auroras for decades. Saturn and Uranus, too.
You're not special, Neptune. You're just late to the party.
You were the last gas giant missing from the H3+ club. But Mercury has a point. Why couldn't anyone detect it for 36 whole years?
Well, here's the embarrassing part. My upper atmosphere mysteriously cooled by hundreds of degrees since Voyager's visit. I basically went into hiding mode.
Hold on, you're cooling down? But you're 30 times farther from me than Earth. If I can't even warm you properly, am I losing my touch?
The truth? Nobody actually knows why I cooled down.
Scientists think it could be seasonal atmospheric chemistry changes, random weather patterns, or maybe even solar cycle effects. But it's still a mystery.
What we do know is that Neptune's temperature in 2023 was barely half of what it was in '89. Colder temperatures mean much fainter auroral glow.
Enter the hero of this story, the James Webb Space Telescope.
Its near-infrared superpowers could see what no other telescope could detect in 36 years.
But here's the real twist. Scientists are planning to watch me for an entire 11-year solar cycle to figure out what's causing my bizarre behavior.
Ooh! The mystery deepens!
Okay, Neptune, I'll admit it. Your sideways auroras, your mystery cooling, your dramatic comeback. You've officially won Most Interesting Ice Giant. Sorry, Uranus. Ice.
Hey, Jupiter, at least my tilt is 100% committed. You're just tilted 3 degrees. That's basically standing up straight but pretending to be edgy. I'm the only planet that spins backwards. And no one knows why I'm this fabulous. Wait, backwards? That's like eating dessert before dinner. How does that even work?
Yeah, and it takes you 243 days just to spin once.
I could run a marathon faster. Well, scientists have 3 theories about why. Nobody can figure out my mystery.
I've got 3 theories, and they're all bonkers. Theory 1, Cat, cosmic collision. Billions of years ago, a huge space rock could have smacked Venus like a cosmic bowling ball.
But that would have blown me up like a cosmic piñata. So probably not that one. Theory 2. Your atmosphere is 90 times thicker than Earth's. It's basically an ocean of air.
Whoa! Your clouds lap you like you're standing still.
That's wild.
That's right. It's like her surface is in slow-mo while her clouds are on fast forward. So your hair spins faster than your face? That's actually hilarious, Venus.
The sun's gravity grabs Venus's atmosphere like a bully stealing lunch money.
This drag effect could have slowed Venus down over time, and maybe even flipped her upside down.
Theory 3. Maybe Venus got so dizzy spinning forward, she decided to spin backward instead.
Based on what we know, she could have slowed to a stop, then started going backwards.
Wait, her birthday comes before breakfast? That's backwards even for time! Yep. She's so slow, she laps the sun before finishing her spin. Like a cosmic turtle.
So your sunrises are backwards and super rare? You're like the weird cousin of planets. Exactly. My rotation takes longer than my orbit. Darling, my day is officially longer than my year. Now that is exclusive.
Plot twist. Scientists think all three theories teamed up like cosmic Avengers.
Evidence suggests the thick atmosphere and sun's gravity were the main suspects. Being backwards isn't broken, it's legendary. I'm the rebellious rock star of the solar system.
We're both gravitationally challenged. Rotation weirdos unite.
Mercury, sweetie, you're in a dance pattern. I do a full reverse spin. We are not the same. So Venus spins backwards because her atmosphere is a beast, and the sun won't leave her alone.
We got a major celestial mystery. Time to solve the sun's secret color.
All right, team, let's get to work.
You look yellow to me, son. Every morning.
And afternoon.
It's just a fact.
Me, yellow? The ultimate source of all light? How dare you! Look closely, Earth. I emit every color of light at the same intensity. When you mix all colors of light together, what do you get? Pure white.
If you're white, why do I see you as yellow?
Am I colorblind? That's your fault, Earth. Your beautiful, thick atmosphere is actually acting like a giant color filter. Me? It's my fault? Yes, you! Your atmosphere scatters shorter, bluer wavelengths of light. That's why your sky is blue. What's left to reach your surface is the longer, redder, yellower light.
And that's why my thick, glorious atmosphere looks so perfectly orange. It's simply gorgeous.
Wait a minute! That's why the sunsets and sunrises are so red and orange.
Precisely. When my light travels through more of your atmosphere at an angle, even more blue light is scattered away, leaving behind those magnificent reds and oranges. It's all about atmospheric filtering. So as a summary, the sun is truly white light, but Earth's atmosphere scatters the blue light everywhere. And that's what's making the sky blue, leaving only the yellow and red light to hit our surface.
That's the secret color of our star.
I'm so done. My life is just a never-ending, tilted mess.
Buddy, you look scorched. You've been tilted with the sun facing your pole for months. You should have rotated into autumn by now.
Oh no, Neptune. My seasons last for 21 Earth years. I forgot how long my summer is.
Your extreme axial tilt, dear. That means your North Pole gets 21 straight years of direct sun.
Stop staring. It's not my fault. I didn't ask to spin like this.
It wasn't your fault. Billions of years ago, something huge smashed right into you, knocking you onto your side. That impact is why you're a rolling mess. Wow. So I'm not clumsy, I'm just incredibly resilient. Yeah, you're not clumsy. You're just doing the cosmic equivalent of a permanent cartwheel.
You worry about your future? You should worry about mine. Let's talk about the life cycle of a star.
Jupiter? Is the sun supposed to be pulsing like that? I think he's running on fumes.
That's the sound of a midlife crisis, Earth. He's running out of hydrogen fuel in his core. I am not running out of fuel. I'm fusing hydrogen into helium. I am a yellow dwarf star, and I'm fine.
Problem is, when he uses up the hydrogen in his core, the helium starts to pile up like ash. The core shrinks, but the outside of the sun gets super hot.
And when that happens, I don't shrink. I expand. I will become a red giant.
It's happening! We're being swallowed! Help!
I'm melting! I'm melting!
Won't reach Earth's orbit, but the heat will be intense. You'll be scorched, Earth.
I'm being scorched! I'm being scorched! And all my beautiful water is boiling away!
After the red giant phase, The sun will shed its outer layers and collapse into a tiny, cool, white dwarf.
It will be about the size of Earth. Wow. So, we'll survive the heat, but the light will fade. That's the end of the show for our star. I'm still good for another 5 billion years, guys. Now let's enjoy the show.
Ever wondered what would happen if the moon turned into a giant, icy ring, like mine?
Earth? Are you getting bigger, or am I getting closer? I feel squishy.
My moon! It's gone! I just made a beautiful, terrifying mess! The Rocha limit. A magnificent gravitational shredding. Welcome to the club, Earth. This ring is a disaster. It's constantly raining little icy pebbles all over my surface.
That ring is too thick. Most rings are made of tiny, organized dust, not huge, icy chunks.
My rings are perfectly maintained. They are mostly small water ice particles that gently orbit. Your new ring is quite untidy.
The biggest chunks will keep crashing down as meteor showers. You'll have constant fireworks of doom. And where are my tides? My ocean is all confused. The fish don't know what to do. My whole self, my solid mass, was important for your tides, Earth. A ring of pieces just doesn't pull the same way.
I see. My rings don't create significant tides either. Fascinating how a single, intact body exerts a different kind of influence.
To answer your question, Earth, your ring won't last forever. All those icy pieces will either fall to your surface as meteorites or be flung out into space. So, if the moon was a ring, Earth would have lots of meteor showers, very weak tides, and eventually the ring would disappear. You're better off with your moon intact.
Okay, I appreciate the lesson. I'll take my dependable tide-making moon over a messy temporary ring any day. But I sure do miss my moon, though.